Hey there everyone, Ramesh here back again with another new brand course titled Spring and Spring Boot Annotations. Well, this is going to be a 3-hour course, and in this course I am going to cover important 25 plus Spring and Spring Boot annotations. Well, in this course I am going to explain all these annotations line by line coding in IntelliJ IDEA. Well, these 25 plus Spring and Spring Boot annotations are very important and frequently asked in interviews. So if you are preparing for the interviews, then make sure that you check out all these 25 plus Spring and Spring Boot annotations. So here, let us take a look into what we will be covering in this course. So we'll begin with add component annotation, next add auto add annotation, next add qualifier, add primary, add bin, add controller, add service, add repository, add lazy, add scope, add value, add property source, add property sources, add rest controller, add response body, add request mapping, add request body, add get mapping, post mapping, put mapping, delete mapping, path variable, request param, and Spring Boot application, and more. So apart from these important annotations, I will be covering few more important annotations. Alright, so let us go ahead and let us begin with understanding add component annotation with line by line coding. Alright, great. Hi everyone, welcome back. In this video, let us take a look into add component annotation. Well, add component annotation indicates that an annotated class is a Spring Bean or a Spring component. Well, add component annotation tells Spring container to automatically create a Spring Bean. Alright, so in annotation based configuration, we can use add component annotation to tell Spring IOC container to automatically create a Spring Bean for a particular class. Alright, so basically Spring offers three kind of configuration styles. First one is XML based configuration, second annotation based configuration, third Java based configuration. And this add component annotation is used in annotation based configuration. Alright, perfect. Now let's go ahead and let's understand more about add component annotation with an example. So let me first create a project using Spring Initializer. So go to browser and just type start.spring.io, and here let us fill up the project information and let us download this project and let us import in a IntelliJ IDEA. Well, here we have different types of projects, so let us choose Maven over here and let's keep Java language as selected, and here let us choose Spring Boot version 3.0.2, and here let us fill up the project metadata. Let's give group as net.javaguides. Well, you can give any group that you want. Next, let us give artifact as Spring Annotations. Next, project name is same as artifact. Next, description demo project for Spring and Spring Boot Annotations. Next, let us give package name as net.javaguides.spring annotations. Next, packaging jar, and let us select Java version 17. Next, as of now, don't add any dependency because Spring Initializer will add a default dependency. For example, if you go to Explorer and go to pom.xml file, and you can able to see here Spring Boot Starter. So this dependency internally add Spring Core dependency. Alright, so as of now, we need a Spring Core dependency to explore Spring Core related annotations. Next, close this and go ahead and click on generate button to generate this project as a zip file. Next, open this zip file in a folder. Next, just unzip this. Alright, next open the IntelliJ IDEA and open this project in IntelliJ IDEA. So click on open and go to the location where your Spring Boot application is present. In my case, it is in downloads folder. Select the project, click on open. Well, this will import Spring Boot project in IntelliJ IDEA. Next, let me demonstrate the usage of add component annotation. Well, add component annotation indicates that the annotated class is a Spring Bean or a Spring component, right? So let us create a class and annotate that class with add component annotation so that Spring IOC container will create a Spring Bean or a component for that class. Okay, so let's go to project, expand this SRC folder, go to main package. Within this main package, let's create one more package and let's call it as controller. Within a controller package, let's create a class. Let's give a name as pizza controller. Alright, next within this pizza controller, let's create a simple method public, let us give string as a return type, and let's give method name as get pizza. Next, this method returns some dummy string, let us say hot pizza. Perfect. Next, we want to make this class as a Spring Bean or a Spring component. So let us go ahead and let us annotate this class with add component annotation. Well, this add component annotation tells Spring IOC container to automatically create the Spring Bean for this class and manage that Spring Bean. We don't have to create object of this class manually using new keyword. Spring container takes a control to automatically create the Spring Bean and manage that Spring Bean for us. Alright, so Spring IOC container is also called inversion of control, right? Because Spring container takes a control to automatically create the objects and manage those objects for us. Next, let us go ahead and let us test this change. Well, in order to test this change, we will create an instance of Spring IOC container, and then we'll retrieve this pizza controller Spring Bean from the Spring container, and then we'll call its get pizza method, and this get pizza method returns hot pizza dummy string. Alright, so let's go to main 80 class over here and go to main method, and within main method we have a run method called. So this run method returns the application context object. Well, basically application context acts as a Spring IOC container, right? And the pizza controller Spring Bean is already there in a Spring IOC container. So let us go ahead and let us retrieve the pizza controller Spring Bean from the IOC container. So here let's have a Java 10 var type, and then let's give variable name context. So this is basically a configurable application context object. So this object provides get bean method to get the particular bean from the IOC container. Alright, so here context, it has get bean method, and notice here there are multiple overloaded get bean methods. We can use appropriate method to get the Spring Bean. Now let's use this second get bean method. It takes class type, okay, and just pass pizza controller as a class type here. And next, let us take the result of this get bean method in a pizza controller variable. Perfect. Next, let us type system.out.println. So here is a shortcut. Just type sysout and hit enter. So IntelliJ IDEA will give sysout statement, and then pizza controller, it has a get pizza method. Okay, now we have retrieved pizza controller Spring Bean from the Spring IOC container using get bean method. Next, let us run this program, and there we go. You can able to see hot pizza is printed in a console. It means the class which we have annotated with add component annotation is working as expected. Alright, so Spring IOC container created the object of this pizza controller class, and it managed that object, and we have retrieved that object by using get bean method over here. Well, one more important point is, by default Spring container will give name to the Spring Bean as a class name, but the first letter of the class name in a lowercase. Okay, and we can also explicitly give a name to the Spring Bean by passing value to this add component annotation. For example, let's say we want to give a bean name pizza demo. So this is the Spring Bean name for this Spring Bean. Next, we can retrieve Spring Bean by using this name. For example, let me copy this bean name and go to main 80 class, go to main method, and here we have used class type to get the bean. Now let us use bean name to get the bean. Next, we need to provide a casting. Alright, next let us run the program, and there we go. It is working as expected. Alright, so this is how we can get the Spring Bean by using bean name as well. And by default, if we don't specify the bean name, then Spring IOC container will provide a default name to this bean name as a class name, but the first letter of the class name is in lowercase. For example, here let me remove this bean name and go to again main method, and here let me pass the default bean name, that is pizza controller, and look at here the first letter in a lowercase, right? So here let me run the program, and there we go. This is working as expected. Well, in real-time project, we use add component annotation to tell Spring IOC container to automatically create the Spring Bean and manage the Spring Bean for a particular class. We don't have to create the object of that class manually using new keyword. Alright, so Spring IOC container takes care of creating and managing the objects of the class for us. Alright, and whenever we required the Spring Bean, then we can simply use @@word annotation to inject that Spring Bean. We can use that Spring Bean. Well, we'll see how to use @@word annotation to inject the Spring Beans as a dependency in upcoming videos. Hi everyone, welcome back. In this video, let us take a look into @@word annotation. Well, @@word annotation is used to inject the bean automatically. The @@word annotation is used in a constructor injection, setter injection, as well as in a field injection. Well, in case of annotation based configuration, we use @@word annotation to automatically inject the Spring Bean. Next, let us go and let's learn more about @@word annotation with an example. So let's go to our project in IntelliJ IDEA, and notice here in previous video we have used add component annotation to tell Spring container to automatically create the Spring Bean and manage the Spring Bean for this pizza controller class. Next, what we will do, we'll see how to use @@word annotation to inject the Spring Bean automatically. So in order to demonstrate this, let me create one more class. So go to base package, and within that let's create one more package. Let's call it as service. Within a service package, let me create a class and let's call it as veg pizza. Alright, within this veg pizza class, let's quickly create one method. Let's say public string, and let's give method name as get pizza, and let us return some dummy string. Let us say veg pizza. Perfect. And in order to make this class as a Spring Bean or a Spring component, we can annotate this class with add component annotation. Alright, next what we will do, we will see how to use @@word annotation to inject this veg pizza Spring Bean in a pizza controller class. So go to pizza controller. Within this pizza controller, let us inject veg pizza dependency or a Spring Bean. So for that, let's first create the instance variable of veg pizza class. Well, @@word annotation is used to inject the Spring Bean using constructor injection, setter injection, and field injection, right? So let us first see how to use @@word annotation to inject the Spring Bean using constructor injection. So here let us create the constructor public pizza controller, and then let us pass this veg pizza variable as a argument, and then this dot veg pizza equal to veg pizza. Next, go to this get pizza method, and here let us remove this hard-coded value, and here let us call veg pizza dot get pizza. Perfect. Next, let us use @@word annotation to automatically inject the veg pizza Spring Bean in a pizza controller. So in order to do that, let's annotate this constructor with @@word annotation. Okay. So this @@word annotation tells Spring container to automatically inject the veg pizza bean using this constructor. Okay, perfect. Next, let us go to main method and let us test this change. So here, let us go and let's run the program. And notice here the output veg pizza. Well, if you look at the flow, go to pizza controller. Within pizza controller, we have injected veg pizza Spring Bean using constructor, and within this get pizza method we are calling veg pizza dot get pizza method, and this get pizza method of veg pizza object returns veg pizza, and this is a veg pizza is printed over here. Alright, it means we have successfully injected the veg pizza Spring Bean in a pizza controller using @@word annotation. Next, let us see how to use @@word annotation with setter injection. So here let me comment out this, and let me quickly create a setter method. Alright, and let us annotate this setter method with @@word annotation. Now this @@word annotation tells Spring container to inject this veg pizza Spring Bean as a dependency using this setter method. Alright, next let us test this change. So go to main method. From here let us run the program, and there we go. You can able to see veg pizza is printed in a console. Alright, so this is how we can use @@word annotation to tell Spring container to automatically inject the veg pizza Spring Bean as a dependency using this setter injection. Next, let us see how to use @attod annotation to inject the dependency using field injection. So here let me comment out this and go to field, and let's annotate this field with @attod annotation. Okay, perfect. Next, go to main method, and here let me run the application, and there we go, veg pizza is printed. Alright, so this is how we can use @attod annotation to automatically inject the Spring Bean as a dependency using constructor injection, setter injection, and field injection. Alright, so this is all about @attod annotation. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into @qualifier annotation. Well, @qualifier annotation is used in a conjunction with @attod annotation to avoid confusion when we have two or more Spring Beans configured for the same type. Well, let me write some code to demonstrate the usage of @qualifier annotation so that you will understand better. So let me go to project in IntelliJ IDEA, and here let me quickly create one interface in a service package. So within a service package, let's create an interface and let's give a name as pizza. And within a pizza interface, let's quickly create a method. So let's give a return type as string, and let's give method name as getPizza. Next, go to veg pizza class and let us implement this interface. So go to veg pizza class and implements pizza interface, and override getPizza method and provide the implementation. So we have already implemented getPizza method. So let's annotate this method with @attod annotation. Next, let us create one more class named non-veg pizza, and that class implements this pizza interface. So go to service package and let's create a new class. Let's give name as non-veg pizza, and this class implements pizza interface and provide implementation for its methods. So just mouse over in this class, click on implement methods and select the method that you want to implement and click on OK. Alright, perfect. And go to getPizza method and provide the implementation. So here go to return statement, and instead of returning null, let us return non-veg pizza. Perfect. Next, let's annotate this class with @component annotation so that Spring container can automatically create a Spring Bean and manage that Spring Bean for this class. Next, in a pizza controller, to achieve loose coupling, we'll inject the interface and will pass the implementation dynamically. Alright, so here let me avoid field injection and let me use constructor injection over here, and instead of injecting the class, let us inject the interface to achieve the loose coupling. So here pizza interface, and go to constructor, and here pass pizza interface as an argument, and here let us remove this, and this dot pizza equal to pizza. Perfect. And here let us remove the reference variable and let us give reference variable pizza. Now we have injected the dependency using pizza interface. Well, Spring team basically recommended to use interface for dependency injection because this will achieve the loose coupling. Alright, and if you can look at the constructor over here, this constructor takes pizza interface as an argument, isn't it? And this pizza interface has a multiple implementations like veg pizza and non-veg pizza. So Spring IOC container will get confused like which pizza interface implementation we have to inject using this constructor, because there are multiple implementations of pizza interface, isn't it? So in order to avoid this confusion or ambiguity, we can use @qualifier annotation. For example, go to this constructor and go to this pizza interface over here, and let us use @qualifier annotation, and let us pass the bean name here. Let us say we want to inject veg pizza bean by using this constructor, then we can simply pass this veg pizza bean name. So by default, Spring IOC container will give bean name to this veg pizza Spring Bean as a class name, but the first letter in a lowercase, right? So veg pizza. Okay, now this @qualifier annotation tells Spring IOC container to inject this veg pizza Spring Bean using this constructor. Okay, perfect. Next, let us test this change. So go to main method and let us run the program, and there we go. We can able to see veg pizza is printed in a console because we have injected veg pizza spring bean in a pizza controller by using add qualifier annotation. So here basically we told explicitly Spring IOC container to inject veg pizza spring bean. Next, if you want to inject non-veg pizza spring bean, then we can simply pass non-veg pizza spring bean name here. For example, non-veg pizza. So this is the name for the spring bean. Next, let us test this change. So go to main method. From here, let us run the application, and there we go. In a console, you can able to see non-veg pizza string is printed because we have told Spring container to inject non-veg pizza spring bean in a pizza controller by using add qualifier annotation. Alright, so this is how we can use add qualifier annotation to tell Spring IOC container to inject a specific spring bean. Okay, so basically Spring IOC container gets confused like which pizza interface implementation it have to inject, because this pizza interface has a multiple implementations, isn't it? So in order to avoid that confusion, we have used add qualifier annotation. Hi everyone, welcome back. In this video, let us take a look into add primary annotation. Well, we use add primary annotation to give higher preference to a bean when there are multiple spring beans of the same type. Well, let us understand add primary annotation with an example. So go to our project in IntelliJ IDEA, and here we have a veg pizza and non-veg pizza classes. These classes implements pizza interface. Well, in previous video, we have seen the usage of add qualifier annotation, isn't it? So if there are two or more spring beans configured for the same type, then Spring IOC container gets confused like which spring bean it have to inject, isn't it? So in order to avoid this confusion or ambiguity, we have used add qualifier annotation. So alternative to this add qualifier annotation, we can use add primary annotation as well. Alright, for example here, let me remove this add qualifier annotation and let us see how to use add primary annotation. Well, let us say the pizza controller want veg pizza spring bean as a dependency. Then we can go ahead and annotate this veg pizza class with add primary annotation. Well, this add primary annotation tells Spring IOC container to give higher preferences for this spring bean while injecting the dependency. For example, if you go to pizza controller, within this pizza controller we are injecting the dependency using this constructor, and notice here we have passed the pizza interface as a parameter to this constructor, and while injecting the dependency, Spring container gets confused like which implementation of this pizza interface it have to inject using this constructor. So to avoid this confusion or ambiguity, we can annotate one of the spring bean using add primary annotation so that Spring IOC container will give higher preferences for this spring bean while injecting the dependency. Alright, now we have annotated veg pizza class with add primary annotation. So Spring IOC container will inject this veg pizza spring bean in a pizza controller. Next, let us go ahead and let us test this change. So go to main method. From here, run the application. And notice here in a console, veg pizza is printed because we have used add primary annotation to tell Spring IOC container to give higher preferences for this spring bean and inject this spring bean in a pizza controller, isn't it? Next, let us say you want to inject non-veg pizza spring bean in a pizza controller. Then you can go ahead and annotate this non-veg pizza class with add primary annotation. Next, go to veg pizza and remove add primary annotation from veg pizza class. Now this add primary annotation tells Spring container to give higher preferences for this spring bean while injecting the dependency. For example, if you go to pizza controller, here we are injecting the dependency using constructor, right? So now Spring IOC container will inject non-veg pizza spring bean using this constructor. Alright, so let us test this change as well. So go to main method. From here, run the application. And notice here non-veg pizza is printed in a console. Alright, so this is how we can use add primary annotation to give higher preferences for a spring bean whenever we have multiple spring beans for the same type. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into at bin annotation. Well, at bin annotation indicates that a method produces a bean to be managed by Spring container. The at bin annotation is usually declared in a configuration class to create spring bean definitions. So let's go ahead and let's see how we can use at bin annotation with an example. So let's go to IntelliJ IDEA and go to our project, And so far we have used annotation based configuration, like we have used add component annotation, we have used add primer annotation, and we have used add attire annotation. Alright, so far we have used annotation based configuration. Next, this add bin annotation is used in a Java based configuration, and in order to use add bin annotation we have to create a configuration class. So here let me quickly create one more package, and let me call it as config, and within a config package let's create a class, let's call it as app config. And in order to make this class as a configuration class, we have to annotate this class with add configuration annotation. Well, whenever we annotate a class with add configuration annotation, then this class becomes a configuration class, and within this configuration class we can define a Spring Bean definitions using add bin annotation. Alright, now let me first remove the annotation based configuration for one of the class. For example, here let me go to veg pizza class, and here we have your add component annotation to tell Spring IOC container to automatically create a Spring Bean for this class, right? Now we need to use add bin annotation to explicitly create a Spring Bean for this veg pizza class, and then we tell Spring container to manage that Spring Bean. Okay, so here what I will do, I will remove this add component annotation. Next, let us see how to use add bin annotation to create a Spring Bean for this class. So go to app config class over here. So this is the configuration class. Within this class we can create a Spring Bean definitions by using add bin annotation. Alright, so here just create a method public, and then let's view return type as pizza. So pizza is the interface and veg pizza is the implementation of this pizza interface. And next let us give method name veg pizza. Next return the object of veg pizza. Now we have created a method, it returns the object of veg pizza class. Next we need to tell Spring IOC container to manage this veg pizza object, right? So in order to do that we can annotate this method with add bin annotation. Now this add bin annotation tells Spring IOC container to manage the object of this veg pizza class. Alright, and if you can closely observe this code, we are explicitly creating the object of veg pizza class, and we are telling Spring container to manage this object. Okay, but in case of annotation based configuration we have used add component annotation. So this add component annotation tells Spring IOC container to automatically create the Spring Bean for this class. Okay, we haven't created the object of this class using new keyword in case of annotation based configuration, but in case of Java based configuration we are using new keyword to create object of this veg pizza class, and we are telling Spring container to manage this object. Okay, so I hope you understood the difference between annotation based configuration and Java based configuration. Now the Spring IOC container is managing the object of this veg pizza class, right? Next let us see how to retrieve this veg pizza object from the Spring IOC container. So go to main method over here, and here we have a application context object. So application context is nothing but a Spring IOC container. We can retrieve Spring Bean from the IOC container by using getBean method. So here let us call context object, it has getBean method, and then pass veg pizza as a class type. Next veg pizza. Okay, now we got a veg pizza Spring Bean from the Spring IOC container. Next let us put the system.out.println and then call veg pizza object, it has getPizza method. Okay, now for time being let me comment out this code. Alright, so next let us run the program, and there we go, veg pizza is printed in a console. It means we have successfully created a Spring Bean by using add bin annotation. Next, one more important point is, by default Spring container will give a name to this Spring Bean as a method name. Okay, and you can also explicitly provide a name to the Spring Bean by using name attribute of this add bin annotation. For example, here this add bin annotation has name attribute, and we can explicitly give a name to the Spring Bean by using this name attribute. For example, here let me give bean name something like veg pizza bean, and we can retrieve this Spring Bean by using this bean name. For example, let me copy this bean name and let me go to main method over here, and here instead of passing the class type, let us pass the bean name and let us provide the casting. Alright, and let us run the application, and there we go. So this is how we can use bin name to get a Spring Bean from the application context. And by default, Spring Container will give name to this Spring Bean as a method name. For example, here let me copy this method name and let me remove the bin name that we have provided explicitly and go to main method and just pass the method name as a bin name, and let us run the application, and there we go, veg pizza is printed. Okay, so by default Spring Container will give a name to the Spring Bean as a method name. Next, let us see how to inject the dependencies. So here let me create one more Spring Bean, public pizza, and let's give method name as non-veg pizza, and then let us return the object of non-veg pizza class, and let us annotate this method with @bin annotation. Next, go to non-veg pizza class and let us remove these two annotations because we are not using annotation based configuration, we are using Java based configuration, right? So again go back to app_config class. Now we have created two Spring Bean definitions by using @bin annotation. Next, go to pizza controller, and here also we have used @component annotation to create a Spring Bean for this pizza controller. Now we need to use @bin annotation, right? So here let me remove @component annotation, and here also let me remove @author annotation because we are not going to use annotation based configuration. Okay, next let us go back to app_config, and here let's create a Spring Bean for pizza controller. So just type public and then pizza controller as a return type and pizza controller as a method name, and then return an instance of pizza controller, and pizza controller depends on a pizza. Alright, so pizza can be a veg pizza or non-veg pizza. Let us say we want to inject veg pizza as a dependency in a pizza controller, then we can simply pass this veg pizza method call. So this veg pizza returns object of veg pizza class. So this is how we inject the dependency in a Java based configuration. Next, let us annotate this method with @bin annotation. Alright, so just try to compare the annotation based configuration and Java based configuration. In case of annotation based configuration, we have used @author annotation to inject the dependency automatically, but in case of Java based configuration, we have to explicitly provide the dependency to a class. Okay, and then we need to annotate this method with @bin annotation so that Spring Container can start managing the object of this pizza controller class. Next, let us go ahead and let us test this change. So let's go to main method over here, and here let me uncomment this pizza controller code, and here let me comment out this veg pizza code. So basically here we have retrieved pizza controller Spring Bean from the application context using bin name. Well, by default Spring Container gives bin name as a method name, and this is what we are using over here. Alright, next let us run this program, and notice here veg pizza is printed in a console because we have injected veg pizza class object as a dependency to pizza controller. Okay, next let us say we want to inject non-veg Spring Bean as a dependency to pizza controller, then we can simply change over here. So here instead of veg pizza, let us call non-veg pizza. Perfect. Next let's go to main method and let us test this quickly, and notice here in the console non-veg pizza is printed. So this is how we can inject the dependency in a Java based configuration. Alright, I hope you understood how to use @bin annotation to create the Spring Bean definitions and how to inject the dependencies and how we can give a name to the @bin annotation. Next, by default the bin name is same as method name. We can specify the bin name using name attribute of this @bin annotation. Well, this we have already seen. Next, @bin annotation provides init method and destroy method attributes to perform certain actions before bin initialization or before bin destruction by a container. Well, let us see how we can use init method and destroy method attributes of @bin annotation. So let's go back to our example, and here in a pizza controller, let us use init method and destroy method attributes. So go to @bin annotation over here. It has init method attribute, and here we can pass the value as a method name. For example, let us say we use a method name as init. So this init method will get called before creating or initializing this class object. Next, it has destroy method attribute, and we can pass a value as a method name. So let's give method name as a destroy. So Spring Container will call this destroy method before it gets shut down. Okay, now let us define this init and destroy method in a pizza controller class. So go to pizza controller class over here, and here let's create a method named init, and within a init method we can write the initialization logic. For example, here let me simply put the system.out.println, and let me print something like initialization logic. And next, let me create one more method, public void, and then destroy, and then let me put the system.out.println, and let me print something like destruction logic. So make sure that the init method and destroy method names should be same as the value we have passed to init method and destroy method attributes. Okay, next let us see how this works. So go to main method. From here let us run the program, and notice here in a console initialization logic is printed and destruction logic is also printed. Alright, so this is how we can use init method and destroy method attributes of admin annotation. Well, the best use case of using init method and destroy method attributes of admin annotation is that whenever you have a requirement to insert records in a database table at application startup, then you can use this init method attribute and you can specify the method name. So this method will basically insert the records in a database while application startup. Next, if you have a requirement to destroy or delete those records from the database table while application shut down, then you can simply use destroy method attribute and you can specify the method. So within this method you can write the logic to delete the records while application shut down. So this is the best use case using init method and destroy method attributes of admin annotation. Alright, so this is all about admin annotation. Hi everyone, welcome back. In this lecture, let us take a look into stereotype annotations. Well, stereotype annotations are used to create a string beans automatically in an application context. So here application context is nothing but a Spring IOC container. Well, the main stereotype annotation is add component annotation. By using this add component annotation, Spring provides more stereotype meta annotations such as add service, add repository, and add controller annotations. The add service annotation is used to create a Spring beans at a service layer. Add repository annotation is used to create a Spring beans for repositories at a DAO layer, and add controller is used to create a Spring beans at a controller layer. Well, in typical Spring based applications, we use 3-layer architecture: controller layer, service layer, and DAO layer. So Spring provides 3 stereotype annotations such as add service, add repository, add controller annotation to create a Spring beans with respect to these 3 layers. For example, in a controller layer we can create a controller classes and we can annotate these controller classes with add controller annotation so that Spring container will create a Spring beans for these add controller classes. In a service layer we can create a service classes and we can annotate these service classes with add service annotation so that Spring container can automatically create a Spring beans for these add service classes. Next, in a DAO layer, we can create a repository classes and we can annotate these classes with add repository annotation so that Spring container can create a Spring beans for these add repository classes. Well, notice here the diagram. Add component annotation is a main stereotype annotation, and the other annotations like add controller, add service, add repository. So these stereotype annotations are derived from the add component annotation. Okay, derived meaning these add controller, add service, add repository. So these stereotype annotations are specialization of add component annotation. Okay, now let us understand more about these stereotype annotations with example. Let's go to our project in IntelliJ IDEA, and within this project let's create 3 packages. So we have already created a controller package and service package. Let's also create a repository package. So we can give name as repository or DAO. So typically different developers give different naming convention. So here let's give a repository. Okay, now within a controller package, let's create a class and let's give name as my controller. Let's annotate this my controller class with add controller annotation. And notice here you have to choose controller annotation from org.springframework.stereotype package. Alright, within this my controller class, let's quickly create one method, public string. Let's give method name as hello. Next, let us return some dummy data over here. So let us say hello controller. Perfect. So we have created my controller class. Within that class we have created hello method. It returns hello controller string, and we have annotated this class with add controller annotation. Well, this add controller annotation tells Spring Container to automatically create a Spring Bean for this my controller class. And if you can go inside this add controller annotation and notice here, this add controller annotation is derived from the add component annotation. Alright, it means this add controller annotation is basically a specialization of this add component annotation. Okay, so let's go back to our controller class and let us test this change. So in order to test this, what we can do is we can get this my controller Spring Bean from the Spring Container. So go to main method over here, and here we have already application context. It acts as a Spring IOC container. So let us retrieve my controller Spring Bean from this application context. So here let me comment out this code, and here let's call context.getBean method and then pass my controller class type. Perfect. Let us take the result of this method in a local variable of type my controller. Perfect. And next let us put the system.out.println statement, and then my controller object, it has hello method. Perfect. Next let us run this program and notice here hello controller is printed. Okay, so basically if you go to my controller, within a my controller class we have hello method. So this hello method returns hello controller. So this is what printed in a console. It means Spring IOC container automatically created a Spring Bean for this class. Next let us go ahead and let us see how to use add service annotation. So go to service package over here. Within this service package, let's create a class and let's give name as my service. And within this my service class, let's create a method public string and let's give method name as hello, and let us return some dummy data. Let us say hello service. Next let us annotate this class with add service annotation. Well, if you go inside add service annotation, this add service annotation is derived from the add component annotation. It means the add service annotation is a specialization of add component annotation. Okay, so whenever you create a classes under service package, then make sure that you annotate those classes with add service annotation. Alright, perfect. Next, in order to test this, what we can do is we can retrieve this my service Spring Bean from the Spring Container. So go to main method. So here we have a context object. It has a getBean method and then pass my service as a class type, and let us get the result of this getBean method in a local variable of type my service. Alright, and next let us put the system.out.println statement and then call my service object. It has a hello method. Next let us run the program and notice here hello service is printed in a console. It means Spring IOC container automatically created a Spring Bean for this my service class. Alright, next let us go ahead and let us see how to use add repository annotation. So go to repository package. Within that let's create a new class. Let's give class name as my repository, and let's annotate this class with add repository annotation. And notice here you have to choose add repository annotation from org.springframework.stereotype package. Next, within this my repository class, let's quickly create a method public string. Let's give method name as hello, and let us return some string here. Let us say hello repository. Perfect. Next, if you go inside a repository annotation This repository annotation is derived from the add component annotation. It means repository annotation is a specialization of add component annotation. Well, whenever you have a requirement to create a repository classes under repository package, then make sure that you annotate those classes with add repository annotation. Next, in order to test this, go to main method and retrieve the Spring Bean. So here, just call context object. It has getBean method and then pass my repository class type. And let us get the result of this method in a local variable of type my repository. And next, let us put the sysout statement and then my repository dot hello. Perfect. Next, let us run the program. And there we go. Hello repository is printed in a console. Alright, so this is how we can use these important stereotype annotations based on the layer. Well, in real-time project, we create a controller class. Within a controller class, we write the logic to handle the HTTP request. And in real-time project, we create a service class, and within a service class, we keep all the business logic. And in real-time project, we create a repository class, and within a repository class, we keep all the database related logic. Alright, I hope you understood how to use these stereotype annotations to create a Spring Beans automatically with respect to different layers. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into IntelliJ annotation. Well, by default, Spring creates all singleton beans eagerly at the startup of application context. It means while starting the application context itself, all the Spring Beans are eagerly created. Well, you can also load the Spring Beans lazily by using IntelliJ annotation. Well, sometime we may have a requirement to load the Spring Beans on demand. In that case, we can use IntelliJ annotation. Well, IntelliJ annotation can be used with add configuration annotation or add component annotation or admin annotations. Next, which one is recommended? Well, eager initialization is recommended because all the Spring Beans are created eagerly at the startup of application context, and if there are any possible errors while creating Spring Beans eagerly at the startup of application context, then those errors will be automatically detected and the application should terminate. But in case of lazy initialization, we can get the errors at a runtime, and this should not terminate the application. Okay, so it is always recommended to use eager initialization to avoid and detect all the possible errors immediately rather than at a runtime. Let's learn more about IntelliJ annotation with an example. So let's go to our project, and here let me quickly create a new package. Let's call it as lazy, and within a lazy package, let me create a new class. Let's call it as eager loader. Alright, and within this eager loader class, let me create a constructor. Let's say eager loader, and within this constructor, let me put the system.out.println. Next, let me print this eager loader class name. So here, let me copy this and paste it over here. Next, create one more class, and let's call it as lazy loader. Perfect. And within this class, let's create a constructor lazy loader, and then within this constructor, let's have system.out.println statement, and let us print this class name. Perfect. Next, let us annotate this class with add component annotation so that Spring container can automatically create a Spring Bean for this class. Next, go to eager loader class, and this class also annotate with add component annotation. Okay, perfect. Next, if we run this application, then Spring IOC container create the Spring Beans for these two classes eagerly. For example, if you go to main method and if you run this program, and notice here eager loader lazy loader. It means Spring IOC container create the Spring Beans for these classes at a application context startup itself. Now, let us see how to use IntelliJ annotation to load lazy loader class on demand. Okay, so here go to lazy loader class, and let us annotate this class with IntelliJ annotation. Next, if we run this application, then Spring container don't create the Spring bean for this class eagerly, because we have annotated this class with @lazy annotation. So this @lazy annotation tells Spring container to load the Spring bean for this class on demand. Okay, so next go to main method, and here let me run the program, and notice here eager loader is printed, but the lazy loader is not printed. It means Spring container created the Spring bean for this eager loader class eagerly at the start of the application context. Next, let us see how to load the Spring bean lazily. So go to main method. Here let's have a context object. It has a getBean method, and then pass lazy loader as a type, and then let us get the result of this method in a local variable of type lazy loader. Here we are calling getBean method to get Spring bean for this lazy loader class from the application context, but this application context don't contain the Spring bean for this lazy loader class, right? So now Spring IOC container will create the Spring bean for this lazy loader class on demand. Okay, so Spring container don't create the Spring bean for this class eagerly at the start of the application context, because this class is annotated with @lazy annotation, right? So Spring container will only create a Spring bean for this class on demand. Okay, now here you can see we are requesting a Spring bean from the application context, so Spring container will create Spring bean for this class. Next, if we run the application, and if you can notice here lazy loader is printed, it means Spring container create the Spring bean for this class lazily. Lazily means on demand. Whenever we request Spring bean from the application context, that time only Spring container create the Spring bean for that class. Okay, so this is how we can use @lazy annotation to load the Spring bean lazily. Next, we can use @lazy annotation with @configuration annotation as well as @bean annotation. For example, if you go to app_config class over here, so here you can annotate this class with @lazy annotation. So whenever you annotate this class with @lazy annotation, then all the Spring beans that we have configured in this class are lazily loaded. Next, we can use @lazy annotation with @bean annotation as well. So here let me remove this, and let me annotate this method with @lazy annotation. Now this Spring bean should be loaded lazily or on demand. Okay, so this is how we can use @lazy annotation to load Spring beans on demand. Okay, so this is all about @lazy annotation. Hi everyone, welcome back. In this video, let us take a look into @scope annotation. Well, the latest version of Spring PMO defines 6 types of scopes: singleton, prototype, request, session, application, and WebSocket. The last 4 scopes such as request, session, application, and WebSocket are available in web-aware application. So in this video, we are going to see how to use @scope annotation to define singleton and prototype bean scopes. Well, @scope annotation is used to define a scope of the Spring bean. We use @scope annotation to define a scope of the bean that is created using @component annotation or @bean annotation. Well, we are going to use @scope annotation to define singleton scope. Well, here singleton scope means only one instance of the bean is created and shared across the entire application, and this singleton scope is basically a default scope. Alright, so in case of singleton scope, Spring IOC container will create only one instance of that particular bean, and that instance will be shared across the entire application. Okay, next, prototype. Well, in case of prototype scope, a new instance of the bean is created every time it is requested. Well, it doesn't matter how many times you request the Spring bean, Spring container will create a new instance for each and every request. But in case of singleton scope, only one instance of the bean is created and it is shared across the entire application. It means it doesn't matter how many times you request a Spring bean from the application context. So application context will return a same instance of the bean each and every time. Alright, so this is the difference between singleton and prototype scopes. Next, let me write the code and let me demonstrate the usage of singleton and prototype scopes. So let's go to our project in IntelliJ IDEA, and here Let me quickly create a new package first. So go to base package, right click new and then choose package. Let's view package name as scope, and within a scope let's quickly create a class. Let's give name as singleton bean. Alright, and within this singleton bean class let's quickly create a constructor singleton bean, and within this constructor let me put the system.out.println and let me print this class name. Alright, so whenever Spring IOC container will create the bean for this class, then this constructor will get called. Okay, next let us annotate this class with add component annotation so that Spring container can automatically create a Spring bean for this class. Next let's create a one more class and let's call it as prototype bean. Alright, within this class let's quickly create a constructor as well, prototype bean, and within this constructor let's have a system.out.println statement and then let us print the class name. Alright, so whenever Spring IOC container create the Spring bean for this class, then this constructor will get called and then this statement will be printed in a console, isn't it? Next let us annotate this class with add component annotation. Okay, now we have created two classes and we have annotated these two classes with add component annotation. Okay, next what we will do, we will use a scope. So go to singleton bean class, let's annotate this class with add scope annotation and let's pass the scope type. So here let's use value attribute and then pass singleton value. Alright, so instead of passing the hard-coded value, Spring provides a constant. So here let me have a configurable bin factory interface. It has a constant that is scope singleton, and if you look at here it has a value singleton. Okay, so instead of passing the singleton hard-coded value, we can use this constant. Okay, perfect. Next let's go to prototype bin class. Let's annotate this class with add scope annotation and let us pass the value. So let's use configurable bin factory. It has a scope prototype constant and this constant provides a value prototype. Okay, perfect. Next, in order to test the usage of add scope annotation, let's go to main method and let's get the Spring beans from the Spring IOC container, and then we'll see how Spring container will return the Spring beans for these two classes. So go to main entry point class, go to main method, and within this main method let me remove this code and let me only keep the context object. So this context object is nothing but a Spring container and it contains all the Spring beans. Now let us retrieve the singleton and prototype Spring beans from this context object. So here let's have a singleton bean object and then context dot get bean and then pass singleton bean class type. Now we have retrieved Spring bean upper type singleton bean class. Next let us retrieve another Spring bean upper type singleton bean class. So here let me copy this and let me paste it over here and let me rename this as a singleton bean 1. This is singleton bean 2 and let me paste one more time and let me call it as singleton bean 3. Okay, now we have retrieved 3 Spring beans from the application context. Next let us retrieve the Spring bean of type prototype bean class. So here let's have prototype bean class and then context dot get bean method and then pass prototype class type over here. Now we have retrieved prototype bean. Next let us retrieve the same bean multiple times from the application context. So here let me copy this and paste it here and let's call it as prototype bean 1 and this is prototype bean 2 and let me paste one more time and this is prototype bean 3. Okay, next let's run this program and let's analyze the result. And there we go. Notice here singleton bean is printed only once, but you can see prototype bean is printed 3 times. Well, here let me print the hash code of these objects so that you will understand better. So here let me write the system.out println statement. So just type the shortcut sysout. This will give system.out println, and here just call the hash code method of this singleton bin1 object. So this statement will basically print the hash code of this object. Next, here let's have a sysout statement and then singleton bin2 and then call its hash code method. And similarly here let's put the system.out println statement and then call singleton bin3. It has hash code method. And similarly here also let's call sysout and then prototype bin1 dot hash code, and then here sysout prototype bin2 dot hash code, and here also sysout and then prototype bin3 dot hash code. So here basically we have printed the hash code for these objects so that we can easily understand the object uniqueness. Okay, so hash code basically returns the unique code for each object, isn't it? So here let us run the program again and just notice the hash code over here. So if you can notice the hash code, the same hash code is printed 3 times. Okay, because if you can notice the code over here, we have retrieved 3 objects from the application context, and application context return the same object 3 times. Okay, and if you can notice the hash code, each object has a unique hash code, right? And you can look at the hash code over here. So same hash code is printed 3 times. It means application context created the single object for this class, and whenever we retrieve the same object multiple times, then application context return the same object. That's why you can able to see the same hash code is printed over here. Alright, so it doesn't matter how many times you request the object, application context return the same object. Alright, next you can see the prototype bin objects. So we have retrieved prototype bin object 3 times, and you can see the hash code is different for each and every object. It means application context basically create the new object for each request. That's why you can able to see the hash code is different for each object. Alright, it doesn't matter how many times you request a Spring Bean for a prototype bin class, then application context will create a new instance for each and every request. Alright, so this is how you can see the difference between singleton scope and prototype scope. Well, one more important point is, by default Spring provides singleton scope for each Spring Bean. For example, if you go to singleton bin class over here, and if you don't specify the scope explicitly using add scope annotation, then by default Spring will provide singleton scope for this Spring Bean. Okay, so in order to demonstrate this, let me comment out this add scope annotation statement, and let's go to main method, and here let me run the application again, and if you can notice here the same hash code is printed 3 times. Alright, great. So this is all about add scope annotation. Hi everyone, welcome back. In this video let us take a look into at value annotation. Well, Spring provides at value annotation to assign a default values to variables and method arguments. Well, at value annotation is mostly used to get a value for a specific property key from the properties file. We can read Spring environment variables as well as system variables using at value annotation. Next, let me demonstrate all these points with an example. So let's go to project in IntelliJ IDEA and let's quickly create a new package. Let's call it as value. Within a value package, let's quickly create a Java class. Let's give name as value annotation demo. Alright, let's annotate this class with add component annotation so that Spring container can create a Spring Bean for this class automatically. Within this class, let's create a variable. Let's say private string, and let's give name as default name. So this is the instance variable. Let's annotate this variable with add value annotation, and let's provide a default value. So let's give default value name something like default name. Alright, next let's create a getter method for this instance variable. So here just right click and then generate and then getter, select the field, click on OK. Now we have created default name field and we have annotated this field with @value annotation and we have passed the default value. So in order to test this, let's get the value annotation demo Spring Bean from the application context and then we'll call this get default name method. So let's go to main entry point class and go to main method. Within the main method here, let's retrieve value annotation demo Spring Bean from the application context. So here context dot get bean method and then pass value annotation demo class type. Perfect. And here let's put the system.out println statement and then call value annotation demo object. It has get default name method and this get default name method returns default name and we have assigned some value to this default name field, right? So this value should be printed in a console. Next, let's go back to main entry point class. From here, let's run the program. And notice here the default name is printed. So this default name value we have assigned to this default name field, right? So this is what printed in a console. Alright, so this is how we can use @value annotation to assign a default value to a variable. Next, let us see how to use @value annotation to get a value for a particular property key from the application.properties file. So here go to resources folder. Here we have application.properties file. Well, by default Spring Boot will read this application.properties file. We don't have to write a code to read this file. Okay, next within this application.properties file, let's configure few key value pair and let's see how to use @value annotation to retrieve a value for a particular key. So here let's say message or else let's say mail dot host equal to gmail.com and let's say mail dot email equal to javaguides@gmail.com, something like that, and then mail dot password secret. Okay, now let's see how to use @value annotation to get values for these keys. So let's go to value annotation demo class. Here let's create an instance variables private string and then host. Let's annotate this field with @value annotation and here is syntax to get a value for a property key. Within a double quote dollar, within a curly braces we need to pass the property key. For example, if you go to application.properties file, this is the key, this is the value. So in order to get this value we have to pass this key to the @value annotation. So let's copy this key, go back to value annotation demo class, go to this field and just paste this key. Okay, next let's create one more instance variable and let's give name as email and let's annotate this field with @value annotation and here is syntax within a double quote within a curly braces just pass the property key. So go to application.properties file, copy this key and paste it over here. Similarly, let's create one more instance variable and let's give name as password. Let's annotate this field with @value annotation and here is syntax within a double quote dollar within a curly braces we need to pass the key. So go to application.properties file, copy this key and paste it over here and here you can see we have a typo, so here we need to provide a dollar. Alright, perfect. Next let us create a getter methods for these three instance variables so that we can get the value for these three instance variable and we can print to the console. So here just right click and then generate getter and select these fields and click on OK. Alright, perfect. Next let us test this change. So let's go to main entry point class, go to main method and here we have already retrieved value annotation demo Spring Bean from the application context. So here let's put the system.out.println and then value annotation demo object. It has get host method. Next let's put one more sysout and then value annotation demo object get email and then one more sysout value annotation demo dot get password. Perfect. Next let us run this application and there we go. You can able to see host gmail.com and then this is the email and this is the password. Alright, so this is how we can use @value annotation to read a value for a property keys from the application.properties file. Well, in real-time project we use @value annotation a lot to get a value for a property key from the properties file. Next, let us see how to use @value annotation to read the environment variables and system variables. Well, by default, Spring Boot will load the environment variables and system variables. Okay. Next, let us see how to use @value annotation to get a value for a specific environment variable or a system variable. So here, let me create an instance variable private string and let's give a name as Java home. Alright, let's annotate this field with @value annotation and here is the syntax within a double quote dollar within a curly braces java dot home. Alright, so this key will provide a value as a complete Java home path. Okay, next here let's create a one more instance variable private string and then let's say home directory. Next let's annotate this field with @value annotation. Next here is the syntax within a double quote dollar within a curly braces just pass the key as a home. So this will give the current home directory and this will give the system variable for a Java home. Okay, next let's create a getter method for these two variables over here. So just right click, choose generate and then choose getter, select these two fields, click on OK. Next go to main depend class, go to main method and here let's put one more system.out.println statement and then pass value annotation demo object and then call get Java home and let's put one more system.out.println statement and then print the current home directory. Perfect. Next let us run this program and there we go. You can able to see in output the Java home path is printed and also the home directory path is also printed. So this is how we can use @value annotation to get a value for environment variables as well as system variables. Alright, so this is all about @value annotation. And in real-time project, most of the time we use @value annotation to get a value for a property key from the properties file. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this video, let us take a look into @PropertySource and @PropertySources Annotations. Well, @PropertySource Annotation is used to provide properties file to Spring environment. @PropertySources Annotation is used to provide multiple properties file to Spring environment. Well, basically we use these two annotations to provide properties file to Spring environment and then we can read these properties file from the Spring environment. Next, these annotations is used with @configuration classes. Next, @PropertySource Annotation is repeatable, means you can have multiple @PropertySource annotations on configuration class. Next, we can use @value annotation and environment classes to read the property file. Well, basically we use @PropertySource and @PropertySources annotations to provide properties file to Spring environment and then we use @value annotation and environment class to read the property file from the Spring environment. Alright, so let me create an example and let me demonstrate all these points. So let's go to our project in IntelliJ IDEA over here. Well, in Spring Boot project we have application.properties file and Spring Boot by default read this application.properties file automatically, but in real-time project we may have a requirement to read the custom properties file in a Spring applications, right? So in this case we can use @PropertySource Annotation to provide the custom properties file to Spring environment and then we can use add value annotation or environment class to read the property file from the Spring environment. So here, first of all, let me create one custom property file. So go to resources folder and let's create one custom properties file. Let's give name as mail.property. Mail.properties. Within this mail.properties file, we can configure all the mail related properties. Okay, for example, here let's say gmail.host equal to gmail.com, and then gmail.email equal to ramesh@gmail.com, and then gmail.password equal to secret. Now we have created mail.properties file and we have defined a couple of properties. Next, let's see how to use add property source annotation to provide this mail.properties file to Spring environment. So in order to demonstrate that, so go to base package over here and let's create a new package. So let's give package name as property source, and within a property source, let's create a new class. Let's give name as app config, and next let's annotate this app config with add configuration annotation. Well, we use add property source and add property sources annotations with add configuration annotation, right? That's why we have created a configuration class and we have annotated it with add configuration annotation. Next, here we can use add property source annotation. Next, we need to provide the property file name. So here the property file is present in a class path. So here let's have a class path keyword and then followed by the property name, that is mail.properties. Okay, so this is how we can use add property source annotation to provide the custom property file to the Spring environment. Okay, next we can read this property file using add value annotation or environment class. Okay, so in order to do that, here let me create a one new class and let's give a name as property source demo, and let's annotate this class with add component annotation. And next, here let me create a couple of properties: private string host, and then private string email, and then private string password. Okay, so basically we are going to read the mail.properties file, right? So if you go to mail.properties file, here we have host, email, password. So these are the properties we are going to read using add value annotation. Okay, so go to property source demo class again, and here let's annotate this host field with add value annotation. And here is the syntax: dollar within a curly braces, we need to pass the property key. So go to mail.properties file, the property key is gmail.host. So let me copy this and paste within this add value annotation. Next, go to email field, let's annotate this email field with add value annotation, and the syntax is dollar within a curly braces, we need to pass the property key. So again go back to mail.properties file, copy this key and paste here. Okay, next let's annotate password field with add value annotation, and then dollar within a curly braces, we need to pass the property key. So go back to mail.properties file, copy this key and then paste over here. Now we have used add value annotation to read the properties. Next, let's create a getter methods to get the values for these fields. So here right click, generate, and then getter, and select the fields, click on OK. Now we have created getter methods for these private fields. Next, let's get this Spring Bean from the Spring IOC container and then we'll call its getter methods. So in order to demonstrate this, go to main entry point class, and here let me comment out this line of code. So only keep this context object. So within a context object we have a property source demo Spring Bean. So let's get this property source Spring Bean from the application context. So here property source demo equal to context dot get bean, and then pass property source demo dot class. Perfect. Now we have property source demo Spring Bean. Next, it has a getter methods, right? So here just put the system.out.println and then call property source demo. It has get host method. Similarly, let us print email and password. So system.out.println and then property source demo dot get email and then sysout property source demo dot get password. Next, let us run this application and let us see how this works. So from here, I'm going to run this application. Well, we got the exception over here. It says conflicting bin definition exception. Well, there are a lot of app config classes in this project. So here, let me quickly rename. So go to property source package. Within that, we have app config class. So here, let me rename this class name from app config to spring config. And then also rename the file. Perfect. Next, go back to main entry point class. Now let's run the application. And there we go. You can able to see we have successfully used @value annotation to read the properties from the mail.properties file. Right? So this is how we can use add property source annotation to provide the custom properties file to the Spring environment. Next, add property source annotation is repeatable. It means we can have multiple add property source annotations with configuration class. For example, here let me create one more properties file. So go to resources folder. Within that, let's create one more custom properties file. Let's give name as messages.properties and let's give few properties like app.name equal to, let's give app name something like Spring Boot app, and next property app.description equal to Spring Boot app description, something like that. Next, let's go to Spring config class. Here let's annotate this class with one more add property source annotation, and then this properties file is present in a class path. So here is a class path keyword and then followed by the custom property file name, that is messages.properties. Next, in order to read this file content, we can use @value annotation. So go to property source demo. Here let's create a private field, private string and then app name. Let's annotate this field with @value annotation and then dollar within a curly braces. Just pass the property key, that is app.name. Next, create one more private field, that is private string app description, and then let's annotate this field with @value annotation and then dollar within a curly braces app.description. Perfect. Next, create a getter methods for these private fields. So here just type get, you will get an intelligence. So just call this get app name. So this will create a getter method for app name field. Next, just type get app description. This will give intelligence to create a getter method for app description field. Perfect. Next, go to main entry point class and here let's put the system.out.println and then property source demo dot get app name and then system.out.println and then property source demo dot get app description. Perfect. Next, let us run this application and there we go. You can able to see the app name and app description is printed. So this is how we can use multiple add property source annotations to provide multiple properties file to the Spring environment. Okay, next let us see how to use environment class to read the property file. So go to property source demo class again and here we have used @value annotation to read the property file. Next, let us see how to use environment class to read the property file. So here what I will do, I will inject environment class. So here make sure that you choose environment interface from org.springframework.core.env package and let's annotate this field with @auto-wide annotation. So this is the field based dependency injection. Next, let's comment out this @value annotation over here. Alright, and go to getter method. So here what we need to do is we need to get the value from the environment object. So here just type environment and then it has get property method, and then we need to pass the property key. So here the host has a property key gmail.host, so let's pass here. Perfect. Next go to get email method, and here just call environment object. It has a get property method, and then pass gmail.email as a property key. Next go to get password method, and here just call environment object. It has a get property method, and then pass property key. So here let me copy this property key gmail.password. Similarly go to get app name method, and then call environment object. It has get property method, and then pass app.name as a property key. And go to get app description method, and here just call environment object. It has get property method, and then pass app.description as a property key. Okay, perfect. Next let's go to main entry point class, and let us test this change. So from here I'm going to run the application, and there we go. You can able to see the output. The host name is printed, email is printed, password is printed, app name is printed, and description is printed. It means we have successfully used Spring environment object to read the property content. Okay, so this is how you can use either @value annotation or environment object to read the property file content. Okay, perfect. Next let me demonstrate the usage of PropertySources Annotation. So go to Spring Config class over here. Here let me comment out these two lines of code, and let me annotate this class with PropertySources Annotation, and then within a curly braces we can pass these two annotations. So here let me copy this annotation, and let me paste it over here, and then comma, and then let me copy this and paste it over here. Okay, so this is how we can use PropertySources Annotation to provide multiple properties file to the Spring environment. Okay, next in order to test this change, go to main entry point class. From here let's run the application, and there we go, we got the output. Okay, so this is how we can use PropertySources Annotation to provide multiple properties file to Spring environment. Okay, I hope you understood how to use PropertySource and PropertySources Annotation to provide the custom properties file to the Spring environment, and how to read the property file content from the Spring environment using @value annotation and environment object. Alright, great. I will see you in the next video. Hi everyone, welcome back. In this lecture, let us take a look into @controller annotation. Well, Spring provides @controller annotation to make a Java class as a Spring MVC controller. The @controller annotation indicates that a particular class serves the role of a controller. Well, whenever you annotate a class with @controller annotation, then that class becomes a Spring MVC controller. Well, controller in a Spring MVC web application is a component that handles incoming HTTP request. @controller annotation is simply a specialization of @component annotation that allows us to auto-detect implementation classes through the component scanning. It means @controller annotation is derived from @component annotation, and whenever we annotate a class with @controller annotation, then Spring IOC container will automatically detect that class, and it will create a Spring bean for that class. Alright, next we typically use @controller in a combination with @request mapping annotation for request handling methods. Next, let me demonstrate all these points with an example. So let me go to IntelliJ IDEA, and let me go to project over here. So first of all, we need to add Spring Boot Starter Web dependency. So go to PropertySources file and go to dependency section over here. Here we need to add a Spring Boot Starter Web dependency in order to build Spring MVC based applications. So here we have Spring Boot Starter. So let's convert it into Spring Boot Starter Web. Alright, so remember, whenever you want to develop the REST APIs or Spring MVC web applications, then you have to use Spring Boot Starter Web dependency. Next, go ahead and click on this Load Maven Changes icon over here. Alright, perfect. Now we have added Spring Boot Starter Web dependency. This dependency internally uses Spring MVC related dependencies. For example, look at here, Spring Web MVC, and this dependency also internally provides embedded Tomcat server to quickly run the Spring MVC application in a embedded Tomcat server. and also this dependency internally includes all the required JSON libraries. Alright, so just remember, whenever you want to develop the REST APIs or Spring MVC based applications, then you can go ahead and use this Spring Boot starter web dependency. Alright, perfect. Next, go to controller package. Within a controller package, let's create a class. Let's give name as book controller. Next, let us annotate this book controller class with add controller annotation, and make sure that you choose add controller annotation from org.springframework.stereotype package. Well, whenever we annotate a class with add controller annotation, then this class becomes a Spring MVC controller, and this class is capable to handle the incoming HTTP request. Next, if you go inside this add controller annotation, this add controller annotation is an alias for add component annotation. It means add controller annotation is a specialization of add component annotation, and whenever we annotate a class with add controller annotation, the Spring IOC container will automatically detect that class and automatically create a Spring bean for that class. Alright, perfect. Next, let's go back to book controller over here. Next, within a book controller, we can create a handler methods that will handle the incoming HTTP request. For example, here, let's create a method public string. Let's give method name hello world. Next, let us return some string. Let us say hello world. Perfect. Now we have created a method. Let's make this method as a handler method by annotating this method with add request mapping annotation, and make sure that you choose add request mapping annotation from org.springframework.web.bind.annotation package. Next, we can specify the URL for this handler method. For example, here let us say hello world. Alright, and if you look at the points over here, we typically use add controller in a combination with add request mapping annotation for request handling methods. So this is what we have done over here. We have used add controller annotation along with add request mapping annotation to handle this incoming HTTP request. Next, we need to annotate this method with one more annotation, that is add response body annotation. Well, whenever you want to develop the REST API using Spring MVC, then you have to annotate a handler method with add response annotation, so that this handler method will return the JSON as a response to the client. Okay, and this add response body annotation internally uses Spring MVC provided HTTP message converters to convert the response into a JSON format, and then it will return that JSON into client. Alright, so just remember, whenever you want to develop the REST APIs using Spring MVC, then you have to use these three annotations. Next, let us go ahead and let us run the Spring Boot application, and let us see how this works. So from this main point class, I am going to run the Spring Boot application, and if you can notice here, our Spring Boot application is running in an embedded Tomcat server on port 8080. Next, let's go to browser. In a new tab, just type localhost 8080/hello world and hit enter, and there we go. The REST API return the response, that is hello world string. Okay, next let's go back to our project and let's go to book controller. Now let's create one more REST API that return the book object in a JSON format. So here what we will do, we'll create a new package. Let's call it as beans, and within a bin package, let's quickly create a class. Let's call it as book, and let us define the instance variables: private int id, private string book title, and then private string description. So here is a typo, this should be string. Perfect. Next, let us go ahead and let's create a constructor. Generate constructor and select all the fields, and also create a getter setter method over here. Right click, generate, choose getter setter and choose all these fields, click on OK. Now we have created a book class. Next, let's go to book controller, and within a book controller, let's create a REST API that return a book instance in a JSON format. So here, just follow the same steps. Let us first create a method public, and in this case let us return book as a return type, and let's give method name as get book, and then here within this method, let's create an instance of book first. Book equal to new book, and then let us pass book ID 1, and let us give the title something like core Java. Next, let us give description, learn core Java and latest features, something like that. Next, let us go ahead and let us return this book instance. So here let us return the book instance. Now we have created a method. Let's make this method as a REST API by annotating this method with @request mapping annotation, and let's specify the URL. Let us say book. Next, in order to return this Java object as a JSON to the client, we have to annotate this method with @responseBody annotation. Alright, perfect. Next, let us go ahead and let us run the Spring Boot application, and let us see how this REST API works. So go to main point class over here, and from here let us run the Spring Boot application. Perfect. Our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let's go to browser, and here let us type the URL localhost 8080/book, hit enter, and there we go. The REST API returns the response, that is the book object in a JSON format. So this is how we develop the REST API using Spring MUC. So let me recap the important points. Whenever we annotate a class with @controller annotation, then this class becomes a Spring MUC controller, and it is capable to handle the HTTP request. And @controller annotation is a specialization of @component annotation, and whenever we annotate a class with @controller annotation, then Spring IOC container will automatically scan that class, and it will automatically create a Spring bean for that class. Next, within a @controller class, we create a handler methods, and we make these handler methods REST API by using @request mapping and @request_body annotation. Next, this @request mapping annotation is used to map the incoming HTTP request to this particular method. Next, @response_body annotation is used to convert the return type of this method into the JSON format, and then write that JSON into HTTP response object, and then it will return that HTTP response object back to the client. Alright, so we'll learn more about this @request mapping annotation in upcoming lectures as well. Alright, so this is all about @controller annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into @REST controller annotation. Well, in order to develop the RESTful web services using Spring MUC, we need to use @controller and @responseBody annotations. Well, if you look at the code snippet over here, in order to develop the RESTful web services using Spring MUC, we have to use @controller annotation and @responseBody annotations. Well, whenever we annotate a class with @controller annotation, then this class becomes a Spring MUC controller, and it is capable to handle the incoming HTTP request. Next, whenever we annotate a method with @responseBody annotation, then this @responseBody annotation tells Spring MUC controller to automatically convert the Java object into JSON, and return that JSON object back to the client. Alright, and this @responseBody annotation internally uses HTTP message converters to convert the Java object into JSON and return that JSON to the client. So this is how the response-body annotation works. Spring 4.0 introduced a new annotation, that is @REST controller annotation, and it is a combination of @controller and @response_body annotations. Well, in order to develop the RESTful web services using Spring MUC, you need to annotate a Java class with @REST controller annotation. So let us go ahead and let us see the usage of @REST controller with an example. So let's go to our project in IntelliJ IDEA, and here we are using @controller and @response_body annotation, isn't it? So here we can also refactor this code, like instead of annotating all the methods with @response_body annotation, we can use @response_body annotation at a class level. For example, here we have annotated this hello world method with @response_body annotation. So let me comment out this, and here to get method also we have annotated @response_body annotation, right? So instead of annotating all the methods with @response_body annotation in this book controller class, we can use this @response_body annotation at a class level. For example, here let's annotate this book controller class with @response_body annotation. Okay. Next, Spring 4.0 introduced a new annotation, that is @REST controller annotation, and it is basically a combination of add controller and add response body annotation. For example, instead of using these two annotations, we can use a shortcut annotation, that is add rest controller annotation. Okay, so add rest controller annotation is nothing but combination of add controller and add response body annotation. For example, if we dive inside this add rest controller source code, and here you can see rest controller is the alias for add controller annotation, and this rest controller annotation is also annotated with add response body annotation. It means add rest controller annotation is a combination of both add controller and add response body annotations. Okay, just remember, instead of using these two annotations, we can use add rest controller annotation like this. Okay, next let us go and let us rerun our Spring Boot application and let us quickly test the REST APIs. Well, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to browser, and here just call this getBook REST API, and there we go. This REST API return the response, that is book object in a JSON format. Next, let us also test the hello world REST API. So here just type the URL localhost 8080/hello world and hit enter. There we go. The hello world REST API is also working as expected. It means whenever you want to develop the RESTful web services using Spring MVC, then we can annotate the class with add rest controller annotation. Okay, so this is a very important point. Whenever you want to develop the RESTful web services using Spring MVC, then you can go ahead and annotate a class with add rest controller annotation. But if you want to develop the Spring MVC web application, then we have to use add controller annotation. Okay, so this add rest controller annotation won't work for Spring MVC web applications. If you want to develop only the RESTful web services, then only you can use this add rest controller annotation. Alright, just try to understand the difference between add rest controller annotation and add controller annotation. Whenever you want to develop the RESTful web services using Spring MVC, then you can go ahead and use add rest controller annotation. And whenever you want to develop the Spring MVC applications that returns the view, then you can go ahead and use add controller annotation. Okay, perfect. In next lecture, we'll take a look into add request mapping annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into add request mapping annotation. Well, add request mapping annotation is used to map web requests to a Spring controller methods. Add request mapping annotation can be applied to a controller class as well as handler methods. So let us understand more about request mapping annotation with examples. So here are the examples that we are going to take a look into in this lecture. So we'll see how to use request mapping annotation at a class level. We'll see how to use request mapping annotation at a method level. We'll see how to use request mapping with multiple URIs. We'll see how to use request mapping with HTTP methods like get, post, put. Okay. Next, we'll see how to use request mapping annotation with produces and consumes attributes. Alright, so let us go ahead and let us see all these examples. So let's go to IntelliJ IDEA and let me go to the project. Well, we have already seen how to use request mapping annotation with method. Next, let us see how to use request mapping annotation at a class level. So here, let us go and let us annotate this book controller class with add request mapping annotation, and let us give the URI. For example, let us say /API. So basically, whenever you want to define the base URI for all the REST APIs within the controller class, then you can go ahead and annotate a class with add request mapping annotation, and then you can define the base URI. So base URI meaning whenever you call these REST APIs, then you have to use this URI as a base URI. Okay, so just remember, whenever you want to define the base URI for all the REST APIs within the controller class, then you can go ahead and annotate that controller class with add request mapping annotation, and then you can specify the base URI. Alright, so in real-time project, basically we annotate a class with add request mapping annotation to define the base URI. Next, let us go ahead and let us run the Spring Boot application and let us see how we can use this base URI. So from here, I'm going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to browser, and here we have the URL localhost 8080/book. So this URL won't work now because we have used the base URI /API, right? For example, if you go to code, here we have used the base URI /API. So we have to use this /API in the URL. For example, if you go to browser, here we have to use localhost 8080 /API/book. So this should work, and there we go. So this is how we use the base URI. Okay, next, if you want to call the hello world REST API, that is localhost 8080/hello world, then this won't work because we have to add the base URI for this REST API. So here let us type /API/hello world. So this should work. Okay, so whenever you want to use the base URI or the common URI for all these REST APIs within the controller class, then you can go ahead and annotate that class with add request mapping annotation, and then you can define the base URI like this. Okay, perfect. Next, let us see how to use add request mapping annotation with multiple URIs. So let's go back to our project, and here let us go ahead and let us add multiple URLs to this REST API. So here we have a single URI, that is /book. Let us add one more URI. So in order to define the multiple URIs, we have to use a value attribute and then within a curly braces. Next, let us add the comma and let us define one more URI. Let us say core-java. Next, let us define one more URI /Java. Alright, now we have defined multiple URIs using add request mapping annotation for this REST API. Next, let us go ahead and let us stop and rerun the Spring Boot application, and let us see how this REST API works. Well, our Spring Boot application is up and running. Next, let's go to browser, and here let us call this get book REST API. So here we are using book URI first. Just refresh. This REST API is working as expected with this URI. Next, let us pass core-java and hit enter, and there we go. This REST API is working for this core-java URI as well. Next, let us pass the Java URI, hit enter, and there we go. Alright, so this get book REST API is working for all these URIs. So this is how we can use multiple URIs using add request mapping annotation for the REST API. Alright, next, let us see how to use request mapping annotation with HTTP method. Well, here if you can see, we haven't specified any HTTP method for this request mapping annotation. Well, by default, if we don't specify the HTTP method for this request mapping annotation, then it will take the HTTP method as a get method. Well, add request mapping annotation has a method attribute, so we can use method attribute to specify the HTTP method. For example, here we can use a method attribute, and then we can specify the HTTP method. For example, request method dot get. Well, if you don't specify the request method explicitly, then by default this add request mapping annotation provides HTTP method as a get. Next, if you want to specify the HTTP method put, then you can simply use request method dot put over here like this. Next, if you want to specify the HTTP method post, then you can simply use request method dot post. Next, if you want to use HTTP method delete, then you can simply use delete like this. Alright, so this is the get book REST API, so we have to use HTTP get method over here. Next, if you want to have create, update and delete REST APIs, then you can go ahead and use the respective HTTP methods like post, put and delete. So we'll see how we can use these different HTTP methods in upcoming lectures. So here just use HTTP get method. Next, let us see how to use request mapping annotation with produces and consumes attributes. So let's go back to our example over here, and let us say this REST API want to produce a JSON and then return that JSON to the client. Then we can explicitly specify the JSON media type over here. For example, here let us use produces attribute and then media type dot application slash JSON. It means this produces attribute tells this REST API that produce the result in a JSON format. Next, we can also define multiple media types. For example, here we can specify the curly braces and then we can specify multiple media types. For example, here media type dot application slash XML. Well, let us say this REST API want to return the result in a different formats. Like this REST API want to return response in a JSON and XML format, then we can specify like this. Alright, next let us say how to use consumes attribute. So let us say this REST API want to consume the JSON that is sent by the client, then we can go ahead and use consumes and then media type application slash JSON. Next, let us say this REST API want to consume the XML data that is sent by the client in a request, then we can go ahead and use application slash XML. And we can also specify multiple media types as well. For example, here within a curly braces we can specify multiple media types. For example, here media type dot application slash JSON like this. Alright, so this is how we can use produces and consumes attribute to specify the media types, and based on the media types the REST API will consume the data and produces the data. Alright, so this is all about at request mapping annotation. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us quickly take a look into at get mapping annotation. Well, the get HTTP request is used to get a single or multiple resources, and at get mapping annotation is used for mapping incoming HTTP get request to a specific handler method. Specifically, at get mapping annotation is a composed annotation that acts as a shortcut for at request mapping annotation plus HTTP get method. Well, basically at get mapping annotation is a shortcut for at request mapping annotation plus the HTTP get method. Next, let us go ahead and let us understand more about at get mapping annotation with an example. So let's go to our project in IntelliJ IDEA, and in previous lecture we have created an example to demonstrate the usage of at request mapping annotation, isn't it? So basically we use at request mapping annotation to map the incoming HTTP request to a particular method, and we use at get mapping annotation to map incoming HTTP get request to a particular method. For example, here let me remove this produces and consumes attribute, and let me keep the at request mapping annotation with multiple URIs and HTTP get method. So as we know that at get mapping annotation is a shortcut for at request mapping annotation plus HTTP get method, right? So here instead of using this much of code, what we can do is we can simply use at get mapping annotation. For example, here let me use at get mapping annotation, and whenever we use at get mapping annotation, then we don't have to specify the HTTP method. So let us remove this. Okay, next if we go inside the source code of get mapping annotation, here you can see get mapping annotation is annotated with at request mapping annotation plus HTTP get method. It means get mapping annotation is a shortcut annotation for request mapping annotation plus the HTTP get method. So get mapping annotation will work same as request mapping annotation plus HTTP get method. Alright, so let's go back to book controller, and if you can notice here the name of the annotation, get mapping. The name itself says that this get mapping annotation is used to map the incoming HTTP get request to this particular method. Alright, so just remember we use at get mapping annotation to map the incoming HTTP get request to a particular method. Next, we can use get mapping annotation to specify multiple URIs. So let me first use a single URI. So in order to define the URI, just pass the double quote. Within double quote we can specify the URI. For example, let us say book. Okay, next let us go and let us rerun the Spring Boot application, and let us see how this get mapping annotation works. Well, our Spring Boot application is up and running. Next, let's go to browser. Here just type the URL localhost 800/API/book, and there we go. The get book REST API is working as expected. So this is how we can use get mapping annotation to map incoming HTTP get request to this particular method. Next, we can use at get mapping annotation to specify multiple URIs. For example, here we can use value attribute, and we can specify multiple URIs like this /book and then /java. Next, let us rerun the Spring Boot application, and let us see whether these multiple URLs work or not. So our Spring Boot application is up and running. Let's go to browser, and here just refresh. Well, this REST API is working. Next, let us pass Java, and there we go. So this is how we can use multiple URIs with add get mapping annotation. Alright, so basically add get mapping annotation is a shortcut annotation for request mapping annotation plus HTTP get method, and this add get mapping annotation, it works same as add request mapping annotation. Okay, so whatever the attribute the request mapping annotation has, same attribute we can use with add get mapping annotation as well. For example, we can use producers attribute to define the media type. For example, here you can see media type application/JSON, and we can also use consumes attribute to define the media type application/JSON. Alright, so this is all about add get mapping annotation. Alright, great. In next lecture we will take a look into add post mapping annotation and add request body annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will take a look into add post mapping annotation and add request body annotation. Well, the post HTTP method is used to create a resource, and add post mapping annotation is used for mapping HTTP post request to a specific handler method. Specifically, add post mapping annotation is a composite annotation that acts as a shortcut for add request mapping annotation plus HTTP post method. Next, add request body annotation is responsible for retrieving the HTTP request body and automatically converting it into Java object. So let us go ahead and let us see the usage of these two annotation with example. So let's go to our project in IntelliJ IDEA and go to book controller, and here let me quickly create a REST API. So let us type public, and let's give return type of the method as book, and let's give method name as create book, and then let us pass the book as a method argument. Next, let us print this book. So here just type system.out.println and then book dot get id, and then system.out.println book dot get title, and then system.out.println book dot get description. Next, let us return this book. Alright, perfect. Now we have created a create book. Next, let us annotate this create book method with add request mapping annotation. Next, this add request mapping annotation is used to map the incoming request to this particular method, right? In this case, the incoming request is HTTP post request. So here basically we need to use method attribute to define the HTTP post method. So here just pass request method dot post, and next we can also specify the URI for this REST API. So here we can use value attribute and then simply pass the URI. Let us say books and /create. So this is how we create a REST API that handles incoming HTTP post request, and here we use add request mapping annotation to map incoming HTTP post request to this particular method. Next, as we know that add post mapping annotation is a shortcut annotation for add request mapping annotation plus HTTP post method. So if you look at this example over here, so add post mapping annotation is a shortcut annotation for this add request mapping annotation plus HTTP post method, right? So instead of using this line of code, what we can do is we can simply use add post mapping annotation. For example, here just remove this add request mapping annotation and just use add post mapping annotation, and whenever we use add post mapping annotation, then we don't have to specify the HTTP post method over here. Alright, perfect. Next, if you go inside post mapping annotation, you can see post mapping annotation is already annotated with add request mapping annotation plus HTTP post method. It means post mapping annotation is a shortcut annotation for add request mapping annotation plus HTTP post method, and this post mapping annotation, it works same as request mapping annotation plus HTTP post request. Alright, next let's go back to our code, and here we can also use different attributes, like we can use consumes attribute to specify the media type. For example, here let us say media type application/JSON. It means this REST API consumes the data that we have specified using media type. For example, here we have specified application/JSON as a media type. So this REST API will consume the data that is in a JSON format from the request. Next, we need to use one more annotation, that is @requestBody annotation. So here go to create book method, and you can see book is the argument for this method, right? So here let us annotate this method argument with @requestBody annotation. Well, this @requestBody annotation is responsible to retrieve the JSON data from the request body, and it will convert that JSON into this book Java object. Okay, and again @requestBody annotation internally uses Spring MVC provided HTTP message converters to convert a JSON into Java object. Alright, so this is how the @requestBody annotation works. Alright, so just remember, @requestBody annotation, it is responsible to retrieve the JSON data from the request body, and it will convert that JSON into this Java object. Alright, perfect. Next, let us go ahead and let us run the Spring Boot application, and let us see how this post mapping annotation works. So from here I am going to stop and run the Spring Boot application. Well, our Spring Boot application is up and running. Next, in order to test this post REST API, we have to use the Postman client. Well, we can call the get REST APIs from the browser itself, but in order to test post, put, delete REST APIs, we have to use the Postman client, isn't it? So let us open the Postman client over here and create a new request, and here let us choose HTTP post method, and let us type the URL localhost HTTP and then localhost /8080/API/ well, if you go back to the code, we have specified the URI /books/created. So let me copy this and let me paste it over here. Next, we need to pass the book object in a body, right? So go to body and select raw here, and then choose content type JSON, and within the body we need to pass the JSON. Okay, next go ahead and click on send button, and there we go. In a response you can see the book object in a JSON format and the HTTP status 200 OK. It means the create book REST API is working as expected. Next, let's go back to IntelliJ IDEA and go to console, and you can see we have printed the book ID, book title, description, right? So this is what you can see in a console. Alright, so basically we use @post mapping annotation to map incoming HTTP post request to this particular method. Next, notice here this post request contains a JSON in a request body, and we use @requestBody annotation to retrieve this JSON object from the request body and convert that JSON object into this book Java object. Okay, now it makes sense, right? So @requestBody annotation is used to retrieve this JSON from the request body, and it convert that JSON into this book Java object. Okay, and in order to convert JSON into Java object, @requestBody annotation internally uses HTTP message converters. Well, here one more important point is, whenever we create a REST API that create a new resource, then that REST API have to return the HTTP status 201 to the client. So in this case, this REST API returns the HTTP status 200 to the client. For example, if you look at the Postman client, you can see the HTTP status 200 OK, right? But ideally, this create book REST API have to return the HTTP status 201 created to the client. So let us go ahead and let us see how to add a HTTP status as a response to this REST API. So here we can use either @response status annotation to specify the HTTP status. For example, here let us use @response annotation, and it has a value attribute, and here we can specify HTTP status created as a HTTP status. Okay, next let us rerun the Spring Boot application, and let us see how this change works. Well, our Spring Boot application is up and running. Let's go back to Postman client, and let's again make the request, and you can see the HTTP status 201 created. So this is how we can specify the HTTP status for the REST API. Well, one more way is we can use response entity class as well. For example, let me comment out this, and here let me use a response entity class. So make sure that you choose response entity class from org.springframework.http package. So response entity is a generic class. We have to pass book as a type, and we need to return the instance of response entity. So here return new response entity, and then we need to pass book as a value to the constructor, and then we can specify the HTTP status that is created. So this is how we can configure the response for the REST API. Okay, next let us rerun the Spring Boot application and let us see how this works. Well, our Spring Boot application is up and running. Next, let's go to Postman client and again make the request, and there we go, HTTP status 201 created, and the response contains the book object in a JSON format. So this is how we can specify the HTTP status in a response of the REST API. Either you can use @response status annotation or response entity class. Alright, so this is all about post mapping and request body annotations. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into @put mapping annotation. Well, put HTTP method is used to update the resource, and put mapping annotation is used for mapping HTTP put request on a specific handler method. Specifically, @put mapping annotation is composed annotation that acts as a shortcut for @request mapping annotation plus HTTP put method. So basically, @put mapping annotation is used to map the incoming HTTP put request to a specific method handler, and @put mapping annotation is a shortcut annotation for @request mapping annotation plus HTTP put method. So let us go ahead and let us understand more about @put mapping annotation with example. So let's go to our project in IntelliJ IDEA and go to book controller, and here let me quickly create a REST API. So here let me first create a method public, and let's give return type of the method as a response entity, and let's pass book as a type. Let us give method name as update book, and then let us pass the method argument, for example int id, and then book. So this is basically updated book that is sent by the client. Next, here let us print the id. So here system.out.println and then pass id. Next, system.out.println and then update book dot get title, and then system.out.println update book dot get description. So here basically we have printed book id, title, description to the console. Next, let us have a return statement, return response entity. Well, response entity class has a generic OK method, so let us use OK method and then pass updated book object in a body. Perfect. So before passing this updated book to the OK method, let us first set the ID to this object. Perfect. Now we have created update book method. It returns updated book to the client. Next, let us make this method as a REST API. Well, traditionally we are using @request mapping annotation, and then we are passing the URL by using value attribute. For example, let's give URL something like books/update/id. So this is a book ID. Next, let us use method attribute to specify the HTTP method. So in this case, we have to provide request method dot put. Alright, so traditionally we were using @request mapping annotation to map incoming HTTP put request to a specific method handler. Later, Spring 4.3 introduced @put mapping annotation, which is a shortcut for @request mapping annotation plus HTTP put method. Alright, so instead of using @request mapping annotation plus HTTP put method, we can simply use @put mapping annotation. For example, here we can replace this annotation with @put mapping annotation, and whenever we use @put mapping annotation, then we don't have to specify the HTTP put method over here. Alright, perfect. Now let us dive into this put mapping annotation source code. And notice here put mapping annotation is annotated with at request mapping annotation plus HTTP put method. It means at put mapping annotation is a shortcut for request mapping annotation plus HTTP put method. Well, notice here the name of the annotation put mapping. Well, the name itself says like this annotation is used to map the incoming HTTP put request to a specific method. Well, notice here the URL. Here we have ID. So this ID is basically called URI template variable. Well, whenever a user hit the request with the URL something like this, HTTP localhost 8080/API/books/update and then ID, let us say book ID 1. So this 1 will be stored in this URI template variable. Next, we need to bind the value of this ID to a method argument. So in order to do that, we use add path variable annotation. So here let's use add path variable annotation. Next, whenever a client calls this update book REST API, then client have to send the updated book information in the request as a JSON, right? So here we have to use add request body annotation to retrieve the JSON from the request and convert that JSON into the Java book object. Alright, so just remember we use add path variable annotation to bind the value of this URI template variable to the method argument, and we use add request body annotation to retrieve the JSON from the request and convert that JSON into Java book object. Alright, perfect. Next, let us go ahead and let us run the Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client over here and let us create a new request, and here let us choose HTTP put method and just type the URL HTTP localhost 8080/API/books and then followed by update and then 1. Okay, next we need to pass the updated book information in the body. So go to body, click on raw here and choose content type JSON, and here let us pass the updated book information. Let us say title core Java and then description, let us say learn core Java with coding example, something like that. Next, go ahead and click on send button, and there we go. In a response you can see the book object in a JSON format and the HTTP status 200 OK. Next, let us go to our project and go to console, and notice here the book ID, book title, book description is printed to the console. Alright, so this is how basically we create the update REST API using add put mapping annotation. Alright, just remember we use add put mapping annotation to map incoming HTTP put request to this particular method, and add put mapping annotation is a shortcut for add request mapping annotation plus HTTP put method. And whatever the attributes that add request mapping annotation provides, all those attributes we can use with add put mapping annotation. For example, we can use multiple URLs using this add put mapping annotation, and we can also use produces attribute to specify the media type, and we can also use consumes attribute to specify the media type. Alright, perfect. So this is all about add put mapping annotation. In next lecture we will take a look into add delete mapping annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will take a look into add delete mapping annotation. Well, delete HTTP method is used to delete the resource, and delete mapping annotation for mapping HTTP delete request to a specific handler method. Specifically, add delete mapping annotation is a composite annotation that acts as a shortcut for add request mapping annotation plus HTTP delete method. Well, we use add delete mapping annotation to map the incoming HTTP delete request to a specific handler method, and delete mapping annotation is a shortcut annotation for add request mapping annotation plus HTTP delete method. Well, let us go ahead and let's create an example to understand more about delete mapping annotation. So let's go to our project in IntelliJ IDEA and go to book controller over here, and here let's quickly create one REST API. So here let us type public and let's give response entity as a return type, and let us pass string as a type, and then let us give method name as delete book. Alright, and let us pass book ID as a method argument. Next here let us have a return statement, return response entity, and it has a OK method. So this OK method internally provides HTTP 200 OK status. Next let us pass some string in the body. Let us say book deleted successfully. Well, in real-time project, basically we call the repository to delete the book from the database table, but this is the simple example to demonstrate the usage of add delete mapping annotation, so we don't have to use any database operation over here. Alright, perfect. Next here what we'll do, we'll print this ID to the console. Now we have created a method that returns book deleted successfully message to the client. Next let us make this method as a REST API by using Spring Annotations. Well, traditionally we were using add request mapping annotation to map the incoming HTTP request to this particular method, right? So let us use add request mapping annotation, and let us use its value attribute to specify the URI. So here /books/delete/ID. So this is the standard URI for this REST API. Next let us use method attribute to specify the HTTP delete method. So here let us call request method dot delete. Alright, so traditionally we were using add request mapping annotation to map incoming HTTP delete request to a specific method. Later Spring 4.3 introduced a new annotation, that is add delete mapping annotation, which is a shortcut for this add request mapping annotation plus HTTP delete method. Alright, so instead of using this add request mapping annotation plus HTTP delete method, let's use the shortcut annotation, that is add delete mapping annotation. So here let's use add delete mapping annotation, and whenever we use add delete mapping annotation, then we don't have to specify the HTTP method over here. So this is the shortcut annotation. Alright, next if we dive inside this delete mapping annotation code, you can able to see here delete mapping annotation is annotated with add request mapping annotation plus HTTP delete method. It means delete mapping annotation is a shortcut annotation for add request mapping annotation plus HTTP delete method. Alright, perfect. Well, notice here the annotation name delete mapping. Well, the name of this annotation itself says like this annotation is used to map the incoming HTTP delete request to this particular method. Alright, next within this URL we have ID. So this ID is called URI template variable, right? Next we need to bind the value of this URI template variable to this method argument. So in order to do that, we use add path variable annotation. Alright, perfect. Next let us go ahead and let us rerun our Spring Boot application, and let us see how this add delete mapping annotation works. So from here I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next let's go to Postman REST client over here, and here let's create a new request, and here let's choose HTTP delete method, and let's enter the URL HTTP localhost 8080/API/books/delete, and then pass book ID, let us say 1. Next click on send button, and there we go. REST API return the response book deleted successfully and the HTTP status 200 OK. Next let's go to IntelliJ IDEA, and you can see in a console the book ID 1 is printed. Alright, so this is how we use add delete mapping annotation to map the incoming HTTP delete request to this specific method handler. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into add path variable annotation. Well, add path variable annotation is used on method argument to bind the value of URI template variable to a method argument. For example, look at here the code snippet. This is the hello world path variable method. It has a ID as a method argument. And look at here, we are using add get mapping annotation to map the incoming HTTP get request to this method. And you can see the URL, hello world/ID/name. And ID you can see here. So this ID is basically called URI template variable. Next we need to bind the value of this URI template variable to the method argument. So in order to do that, we use add path variable annotation. And look at here the response of this REST API in a screenshot over here. So client basically uses this URL to call this REST API, that is localhost 8080/hello world/100/Ramesh. So 100 is basically a ID, Ramesh is a name, and this 100 value will basically stored in this URI template variable, that is ID, and Ramesh name is basically stored in this URI template variable, that is name. Next we need to bind the value of this ID to a method argument, right? So in order to do that, we use add path variable annotation. Next, let us see a few more examples in an action to understand more about add path variable annotation. So let's go to our project in IntelliJ IDEA, and here let me quickly create a REST API that demonstrates the usage of add path variable annotation. So here let us type public and then response entity as a return type. So this is generic class. Let us pass book as a type, and let us give a method name something like path variable demo. Alright, next let us annotate this method with add get mapping annotation, and let us pass the URI, let us say /books and then /ID. Alright, next in order to bind the value of this ID to a method argument, we should have a method argument, right? So here int ID. Next we need to bind the value of this URI template variable with this method argument. So in order to do that, we use add path variable annotation. Next within this method, let's have a system.out.println and let us print this ID. Okay, next let's create a book instance over here. Book equal to new book. Alright, and then book dot set ID and then pass ID. And next let's have a return statement, return response entity dot OK and then pass book object. Perfect. And look at here, we got the compilation error. It says create a constructor with no argument. So here go to book class, and here let's quickly create a no argument constructor, public book. Alright, next let's go back to our REST API. Alright, now we have used add path variable annotation to bind the value of this URI template variable to this method argument. Next let us rerun our Spring Boot application and let us see how this REST API works. So from here I am going to stop and rerun the Spring Boot application. Well, this is the get REST API, so you can use either browser or a Postman client to test this REST API. So I am going to use Postman client. So here let's create a new request and then http get, and then the URL is http localhost 8080/API/books followed by the book ID, let us say 1. Okay, next click on send button and we got the response. It contains ID 1. We haven't passed a title description in the URL, that's why title description are null here, and we have passed 1 as a book ID, that's why we got the ID 1 here. Okay, next let's go to our code, and in a console you can see the book ID 1 is printed. Alright, it means the add path variable annotation is working as expected. Next let us go ahead and let us see how to use multiple URI template variables in the URL. Right now we have only one URI template variable, that is ID, right? So we can have multiple URI template variables, for example ID and then title and then description. Alright, next in order to bind the value of these URI template variables to a method arguments, we have to use add path variable annotation. So here first of all we need to have a method argument, the corresponding method argument like string title and then string description. Perfect. And in order to bind the value of this title URI template variable with this method argument, we have to use add path variable annotation. Next, in order to bind the value of this description URI template variable with this method argument, we have to use add path variable annotation. Next, let us set title description to this book object. So here book dot set title and then pass title, and then book dot set description and then pass description. Alright, so this is how we use multiple URI template variables in a URL. Next, let us go ahead and let us rerun our Spring Boot application and let us see how this works. So from here I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client, and here let us pass multiple values in a URL. For example, here book ID and then followed by the book name, let us say Core Java, and then followed by the description, let us say Core Java description, and go ahead and click on send button, and there we go. In a response you can see book ID, book title, book description. Alright, so let us go back to our project in IntelliJ IDEA. Now we will see one more use case, like let us say if the URI template variable name and method argument name both are different, then what will happen? So if the URI template variable name and method argument name are different, then we need to pass the URI template variable name to the add path variable annotation. For example, here let us say the URI template variable name is title and the corresponding method argument name is book title. Next, in order to bind the value of this URI template variable to this method argument, we have to use add path variable annotation, right? But look at here, the URI template variable name and the method argument name, both name are different. In this case, we have to pass the name of this URI template variable to this add path variable annotation. For example, here we need to pass URI template variable name here. Otherwise, add path variable annotation won't able to bind the value of this URI template variable to method argument. Okay, perfect. Next, let us say the URI template variable name is book description and the method argument name something like book description. And if we don't pass this URI template variable name to the add path variable annotation, then add path variable annotation won't able to bind the value of this URI template variable to this method argument. Okay, so let me demonstrate this as well. So here let me pass book description. Okay, next let us stop and rerun the Spring Boot application and let us see how this works. So go to Postman client and here let us make this request again, and you can see internal server error. So let us see what is the issue. So go back to IntelliJ IDEA and here you can see the error, required UI template variable name, book description, and the method parameter type string is not present, and you can see the exception, missing path variable exception. Alright, so it means whenever the UI template variable name and the method argument name both are different, then we have to pass the URI template variable name to the add path variable annotation. Okay, for example, here let me copy this description name and go to add path variable annotation, and here let me pass this URI template variable name here. Okay, so this is how the add path variable annotation works. Now if I stop and rerun the Spring Boot application and if I call this REST API, this should work. Okay, so let me go to Postman client and let me call this REST API again, and there we go. You can able to see title, description, and there are no errors in a console. Alright, so remember this is a very important point because in real-time project most of the developer make this kind of mistakes. Okay, so this is how we use add path variable annotation to bind the URI template variable to a respective method argument. Okay, so this is all about add path variable annotation. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into add request param annotation. Well, we use add request param annotation to extract query parameters from the request. Well, sometime client may send a request URL something like this, localhost 800/student/query, and then followed by the query parameters. So you can able to see here key value pair, first name Ramesh, last name Fatari. So this is basically called a query parameters in the URL. Next, look at here the code snippet. This is the REST API that handles this kind of request URLs, and basically the URL contains the query parameters like first name Ramesh, last name Fatari. Next, this is the REST API that extract the query parameters value using add request param annotation. For example, here we use add request param annotation, and then we need to pass the query parameter name, that is first name, and then this add request param annotation will bind the value of this query parameter name to this first name method argument. Okay, next, here also we are using add request param annotation to bind the query parameter value to this last name method argument. So this is how we use add request param annotation to extract the query parameters from the request. Next, let us go ahead and let us see one more example to understand more about at request param annotation. So let's go to IntelliJ IDEA, and here let me quickly create a one REST API that demonstrates the usage of at request param annotation. So here public and then response entity as a return type. So this is generic class. Let us pass book as a type and let us give a method name as request param demo. Alright, and let us pass the method argument, let us say string title. So before that let's have int id. Perfect. Next, within a method let's have a system.out.println and just print this book id, and then let's have one more system.out.println and let us print the book title. Alright, next let us have a return statement. Before that let's have a book object, book equal to new book, and then let us set the id, book dot set id, and then pass id. Next, book dot set title and then pass title, and next let us have a return statement over here, return response entity dot ok, and then pass book object in a body. Perfect. Next, let us annotate this method with at get mapping annotation, and then let us pass the URI slash books slash query. Okay. Next, let us say a client uses the URL something like http colon localhost 8080 slash books API books, and then query, and then query parameter, let us say id equal to 1, and then ampersand, and then title equal to core Java. So let us say client uses this kind of URL to make the REST API call. Then we have to bind the value of these query parameters to the method arguments, right? So in order to do that, we use at request param annotation. For example, here let us use at request param annotation, and then we need to pass the query parameter name, that is id and title. So here let us use its name attribute and let us pass id as a query parameter name. Similarly, go to title field and here let us use at request param annotation and then pass query parameter name, that is title. Alright, so this is how we use at request param annotation to extract the query parameters from the URL and bind the corresponding query parameter value to the method arguments. Alright, next let us go ahead and let us rerun our Spring Boot application and let us see how this at request param annotation works. So from here I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let me copy this URL and let me go back to Postman as client over here, and here let me create a new request. Let us choose http get method and then pass this URL in the URL section and go ahead and click on send button. It says could not send request, so let me check what is the issue. So you can see the URL http and then colon and then slash and then localhost 8080 slash API slash books slash query, and then these are the query parameters. Next, click on send button and there we go. You can able to see the response id1 title core Java, and notice here we have passed the book id1 title core Java in a request URL, and that is what reflected in a response. Next, let's go back to our project in IntelliJ IDEA, and if you go to console you can see the id and title is printed in a console. Alright, it means at request param annotation is successfully extracted the query parameters from the request URL, and it bind the value of these query parameters to corresponding method arguments. Okay, so we can use multiple query parameters in the request URL like this id title. Next, we can also use the description as well. For example, here description, and in order to bind the value of this description query parameter name, we use at request param annotation. For example, here let me first give the description core Java description, and next here let's use the corresponding method argument string description, and in order to bind the query parameter value to this method argument, we have to use at request param annotation, and then we need to pass the query parameter name, that is description. Next, here go to book object, and then before return statement just set the description to the book object. So here set description and then pass description. Perfect. Next, let us stop and rerun the Spring Boot application, and let's go to PostgreSQL client, and here let us pass the description in a URL ampersand and then description equal to, let us say, core Java description, something like that. Next, go ahead and click on send button, and there we go. In a response you can see book ID, title, description. Alright, so this is how we use at request param annotation to extract the query parameters from the request URL and bind the value of query parameters to the corresponding method arguments. Alright, great. I will see you in the next lecture. In this video, what we'll do, we'll understand one important annotation, that is at Spring Boot application annotation. So this is a very important annotation, and it does a lot of things while running our Spring Boot application. Okay. Alright, and this annotation should be annotated for our Spring Boot application starter class or Spring Boot main entry point class. Okay, this annotation should be annotated for this starter class. Okay, and now if you can go inside this source code of this annotation, you can see this annotation internally contains three annotations. First is Spring Boot application, Spring Boot configuration annotation, enable auto configuration, and component scan annotation. Alright, at Spring Boot application annotation internally contains these three annotations. Alright, let me show you in a diagram. So look at here, at Spring Boot application annotation is the combination of at Spring Boot configuration annotation plus at enable auto configuration plus at component scan annotation. And at Spring Boot configuration annotation internally uses at configuration annotation. So let me show you in a source code. So look at here, this is the at Spring Boot configuration, and it internally uses at configuration annotation. Okay, so understood. Just remember, Spring Boot application annotation, it internally contains these three annotations. Now let's understand these three annotations step by step so that you will be able to understand the usage of Spring Boot application annotation. Okay, as we know, Spring Boot configuration annotation internally uses at configuration annotation, so this annotation should work as at configuration annotation. Now let's understand the usage of at configuration annotation. So this is very important annotation, and we use at configuration annotation to configure, to provide a configuration as Java-based configuration. Okay, Java-based configuration. So there are three types of configuration we can do in a Spring-based application, right? One is XML-based configuration, alright, and second is Java-based configuration, and third is annotation-based configuration. Okay, so in order to do Java-based configuration, we use at configuration annotation. So basically we create a Java class, and then we annotate that Java class with at configuration annotation, and then that Java class becomes a configuration class, and we can define all the Spring related configuration in that class. For example, let's say I can create a class over here. For example, let's say Spring config. Okay, so this is a normal Java class. Okay, it doesn't related to Spring. Now what we can do, we can use at configuration annotation on top of this class, so that this class becomes Spring Java based configuration class. Alright, now we have annotated this class with add configuration annotation, and now this class becomes a Java based configuration, and we can define a beans, or we can configure beans inside this class. Okay, understood the usage of add configuration annotation. So we use add configuration annotation to make a Java class as a Spring Java based configuration class, and we can define the beans inside this configuration class. So next is add enable auto configuration class. So this annotation is very important. This annotation enables auto configuration classes for our Spring Boot application. So whenever our Spring Boot finds Spring Starter web dependency in a class path, then this annotation basically enable a dispatcher servlet auto configuration class, view resolver auto configuration class, and other auto configuration classes. So this annotation is responsible to enable auto configuration classes whenever our Spring Boot application will find dependencies on a class path. Okay, just remember this annotation. And next is add component scan annotation. So this annotation is also very important, guys. So we use add component scan annotation to scan the Spring components in a particular package. For example, look at here, this is the project structure of our Spring Boot application, and this is called a base package for our Spring Boot application. Let me create one more package. Let's say .sub1, and let me create quickly one more package. Let's say .sub2. Okay, and as we know that this entry point class, that is Spring Boot application entry point class, annotated with add Spring Boot application annotation, and it internally contains add component scan annotation. Okay, now what this annotation will do is it will automatically scan all the Spring components inside this base package plus its sub packages. Okay, alright, so add component scan annotation will scan all the Spring components within a base package plus all the packages, the sub packages inside this base package. A demo is the base package, and within a demo we have sub1, sub2. So these are the sub packages of demo package, right? And add component scan annotation will scan all the Spring components present in demo package as well as sub1 and sub2 package. So Spring component means the class which is annotated with Spring provided stereotype annotations. For example, let me quickly create a class. Let's say Spring component, and I will create a method here, public string, let's say get message, and I will return some string here. Let's say hello world. Okay, so this is the class. It has a method, get message method, and this is not a Spring component yet. Okay, we need to annotate this class with some Spring provided stereotype annotation. For example, let's say if we use add component annotation. So whenever we add component annotation to any class, then this class becomes Spring component. Okay, and this add component scan annotation will scan this component, okay, during our application startup, and then it will scan and then it will register this component in Spring application context or Spring IOC container. Alright, I hope you understood the flow. Now what we'll do, we'll get this bin, this Spring component bin from the application context. So component, let me rename this. Okay, so go to our Spring Boot main entry point class. It has a main method and this is run method. So run method returns application context, right? That is configure application context, and this is nothing but a Spring IOC container. It contains all the Spring components. Now let's go ahead and let's get that application context from the run method. Configurable application context, and let's say application context. Okay, now what we'll do, spring component equals to application context, and then we have a get bin method. So whenever you want to get a bin, that is spring bin, then you can call get bin method, and there are overloaded get bin methods, so you can choose appropriate. So I'm going to choose first one, and then I will just pass spring component here dot class. Now we got spring component from the application context. So here application context is nothing but our Spring IOC container, and Spring IOC container contains all the Spring beans, and Spring component is nothing but a bin. Okay, because we have annotated this Spring component with add component annotation. Okay, so this is the annotation based configuration. So now what I'm going to do is I'm going to put the sys out here, and I'm going to call get message method. Now let's run the Spring Boot application and let's verify whether we have configured this component properly or not. So look at here, hello world. It means that add component scan annotation successfully scanned the sub package. Okay, I hope you understood the usage of add component scan annotation. So add component scan annotation basically scan the base package. Along with that, it will also scan all the sub packages for Spring components. So here we have a Spring component or Spring bean, and it is present in a sub 1 package, and sub 1 package it is stored in a base package. So this is the hierarchy. Alright, I hope we understood the usage of add configuration annotation, add enable configuration annotation, and add component scan annotation. Alright, great. Alright, once we understood add configuration annotation, add enable auto configuration annotation, and add component scan annotation, then let's go back to add Spring Boot application annotation. So as we know, add Spring Boot application annotation is a combination of these three annotation. So instead of using these three annotation, we can use this single annotation, that is add Spring Boot application annotation. That's why whenever we create a Spring Boot application using Spring Initializer, by default Spring Boot will add this annotation to starter class or Spring Boot entry point class. Okay, so instead of using these three annotations, we can use this single add Spring Boot application annotation. And so this single annotation will do the purpose of these three annotations. Okay, I hope you understood the usage of add Spring Boot application annotation. So this is a very important, and just remember what this annotation does behind the scene. So it will auto configure the class as a Java configuration class, and it will enable the auto configuration, and it will scan the components in a base package as well as its sub packages. Okay, great.